this is Jack Jackson. In this video, we're going to talk about transformations of graphs a little bit. In fact, in the next series of several videos, what we're going to do is we're actually going to review some concepts from pre-calculus, and then we're going to actually see how these can connect to derivatives. So basically, remember from our study of pre-calculus that there are certain types of basic geometric transformations, like translations, reflections over the x-axis, or over the y-axis, or over the line y equals x, rotations of at least 180 degrees about the origin, and a few basic things like that that we can do. Also some vertical and horizontal stretches and compressions. And all of those things, we know how to make relatively simple changes to the formula in the table to get the corresponding thing to happen to the graph. And so one of the basic things that we remember is that the change to the formula involves the inverse of what's happening everywhere else. So the change in the formula is backwards, or opposite of what happens everywhere else. So give you an example. If you replace x by x minus h in the formula, that's going to result in a horizontal translation. And what's going to really happen is, in the formula you've replaced x by x minus h, but what really happens everywhere else is that you actually add h to x, leaving the y alone in the table of values. And of course that's how it changes the table from pre-image to image point. And what that does then with the graph is it's going to translate it horizontally. So if you're replacing, say, x by x minus 3, the graph will go 3 units to the right, and so forth. So it's kind of backwards there. Now, in this next series of videos, we are going to go over these basic concepts of each basic type of transformation, and we're going to do it in a very quick way. But I strongly encourage you, if you don't remember all this stuff very well, to go back and see some of my other videos. So I have an entire playlist, Algebra Unit 5, Transformations of Graphs, and where we develop these ideas very carefully and slowly with algebraic functions, particularly power functions and then other functions, and relations in general. And then we also have three specific videos, 2.71, 2.72, and 2.73 from my trigonometry second playlist, in which we're investigating these transformation ideas specifically applied to trigonometric functions. So we look at things like, for example, a sine wave and how do we change its amplitude or period and so forth, or phase shift, for example. Now, in the following sections in the corresponding videos, we're going to take each of the most basic types of transformations that I kind of mentioned just a second ago here, and we're going to investigate these, the basics of the algebraic functions, how these work, and then after this series of videos, there will be a summary video, and then there will be some videos showing how these things work when we translate. For example, if we translate a function, what happens to the derivative of that? How do the two derivatives compare, and so forth? And we'll look at see how some of these transformations affect the derivatives. So some basic things that you should know are transformations themselves are functions. So they take a pre-image point anywhere in the plane and send it to an image point in the plane. So you can think of it point by point as matching it. And we're also going to think of it this way, as where we restrict our attention to how they affect the graph of a certain relation. So you can think of it individually at the point level, how things are moved around from pre-image to image, input to output there on the transformation. But we can also think of it collectively as a set of points, how these things are moved around when you take a graph and how that entire graph is moved to another one collectively. So they take an input, which is a relation, and an output is a new relation, so the transformation is actually a function itself. So we're going to describe how changes in the formula, table, and graph work and how they're related to each other for several standard types of transformations for which it's easy to see how the formula and table are modified and graphed. And we will illustrate these with a couple of examples, mostly with power functions. And we'll see how these change the formula table and the graph. And the tables, I want you to notice when they're in these following videos, and are set up so that when things are lined up like this, for example here, these 2 points are lined up so that the blue point is the pre-image point and the red point is the corresponding image point. So this 4, 1 is not just any point on the image graph, but specifically the one that's related to or comes from this pre-image point of -1, 1 on the pre-image graph. At the end, we'll come up with a table that's going to summarize kind of all these transformations on a single page of notes. And remember again that the formula is backwards from the actual change of the table and the graph because the inverse operation is applied there. Now, a couple of words I want to define here, and then we'll stop this video and then go into the next a series of short videos on each of the types of transformations. So a fixed point of a transformation is an individual point whose image is the same as its pre-image. So when you apply the transformation, that point as an individual point does not move at all. Okay, when we have a relation, some set of points, for which a transformation collectively maps the pre-image set of points to the same image set of points, even though some of the points may not be fixed individually, we say that the relation has symmetry with respect to that transformation. So you have a graph, and when the dust settles, the image graph is the same as the pre-image graph. We say that that relation has symmetry with respect to that transformation. Okay, so let's. I think that will stop there. We'll then have a series of videos, one on translations, and then we'll follow that up by vertical and horizontal strains, and so forth.